What up, guys? So let's actually answer these problems. They're actually coming from theorem number 1, right? So if you remember the last video, we were solving this theorem, or we're proving this theorem. So that theorem actually comes with questions. So let me just give you this advice. When you do a theorem, you need to learn something from that theorem. So we use the knowledge that we have actually grabbed from that theorem to answer these questions, right? So remember what we have actually said. So the way we're going to answer this is we are just going to read the statement and then we interpret the statement and then we're going to answer. So let's just go. The first thing is we are being told that AB is the chord of the circle. So this is AB, right? So we are being told that AB is the chord of the circle. Now, if you go back to the previous video that we have just done, what did you realize? You realize that we were trying to prove that this and this are the same. We were trying to prove that AC actually equals to BC, isn't it? So that is the information that we know. We know that AC equals to BC. And we are being told that O is the center of the circle. So this is good. So O is the center of the circle. And we are being told that AB equals to 24 centimeter. So if AB equals to 24 centimeter, this is AB. If AB equals to 24 centimeter, it means that, AC has to be 12 centimeter and CB has to be 12 centimeter as well. So that when we add them, they're going to give us a total of 24 centimeter. Do you get it? So like Euclidean geometry is not hard. Once you understand your theorem, you use the information or the knowledge that you have learned from your theorem to actually interpret the diagrams that you are actually given, right? And now we are being told that O is the center of the circle. So what do we realize? We immediately realize that OA, do you see OA, right? You see this OA? OA and OB are the same, or they are equal. Why? Because they are actually radius, right? So they are actually radius. But do you know what else is a radius? Even OE is a radius. OE is a radius as well, which means that these three lines are the same, or they are equal. Does it make sense? So these three lines are actually equal. All the lines that I've actually painted in blue, they are actually equal. And why are they equal? Because they are all radius. Now, what are radius? Radius are a line that actually start from the center of the circle all the way to the circumference of the circle, right? So if you check all the lines that I've actually painted with blue, they started from the center of the circle and they've actually expanded to the circumference of the circle. And because of that reason, we call them radius. And we know for a fact that radius are actually the same, or they are equal. So now let's just look at something really interesting here. We realize that we are being told that OF, we are being told that OF actually equals to what? In fact, let me just do it like this. If you check to 1.2 here, I shouldn't have done that, but let me just do it. We are being told that CE equals to 8 centimeter. This is CE, do you see it? So we are being told that CE equals to 8 centimeter, and we are being told that, OC equals to X. So in other words, this entire line, do you see this entire line? This entire line of OE, it actually equals to X. It actually equals to X plus 8, isn't it? Like this entire line, it's actually X plus 8. So you realize that we said that this line equals to this line and it also equals to this line. So what is that actually going to do? It means that we are also going to say that this line, do you see this line? It is also going to be X plus 8. And why do we say that it is X plus 8? Because it equals to the line OE, which is a radius. And it is also safe to say that even this one, it is X plus 8 as well. So now we also remember that this is your 90 degree. These things, guys, they are so simple. What you have to do is to remember all your theorem and use the information from your theorem to answer these questions. Now let's just look at 1.1. 1.1, they say we need to find AC. We've already found that, right? Like we've already found that AC equals to 12 centimeters. I'm just going to write 12 here. We've already found that. It's really simple, isn't it? Now they say we need to calculate the value of x if CE is 8 centimeters. So how do we find this value of x? Now I want to show you something. Let's just say in triangle OCA, right? So in triangle OCA, what are we looking at? This is triangle OCA, isn't it? So I'm just going to draw it here. So let me just draw this triangle OCA, and I want to show you something. So I'm just going to draw it like this. So this is A, this is O, and this is C, right? You realize that this is 12. Okay, this thing is actually glitching. And this is X, and this is actually X plus 8, right? This is actually X plus 8. So what are we actually trying to do with this? I'm just going to say, do you remember the theorem of Pythagoras that you have actually learned in grade 10, even grade 9, I don't know. But if you remember the theorem of Pythagoras, it says that, r squared equals to x squared plus y squared. Now, what is your value of r squared here? This is your r, this is your x, and this is your y. So I'm just going to substitute. You see this side, which I say it is r, it is actually AO. Do you see it? So I'm just going to say this is AO, and then I square it, equals to. So the value of x, it's actually AC. Do you see it? So this is AC squared plus. So the value of y, it's actually CO. So I'm just going to write it as CO, and then I square it. So what is the value of AO? So the value of AO, it is x plus 8, and then I square it, plus or equals to. So the value of AC, it is just AC, it is 12. So I'm just going to write it as 12. I square it plus, and then this other one is just x, and then I square it. Now I need to expand this. It's just going to be x plus 8, and I'm just going to have another x plus 8 actually equals to, I'm going to use my calculator. What is 12 squared? I know the answer, but I prefer that you use your calculator because you guys end up making very stupid mistakes that you shouldn't have made, right? So let's actually expand this. Just going to have x squared plus 8x plus 8x. What is 8 multiplied by 8 is the same. So it's just going to be 64. So what I've done here is to cross multiply. I said what is x times x, what is x times 8, what is this times this, what is this times that, and we actually get this, right? So this is actually going to equals to 144 plus x squared. So what I want to do is I'm just going to have x squared. What is 8 plus 8, ladies and gentlemen? I'm just going to find 16x plus 64. This actually equals to 144. Oh my God, this thing is glitching like crazy, plus x squared. So you realize that these two are going to cancel out, isn't it? They are going to cancel out. So I'd be left with 16x actually equals to, if I take this to the other side, I'm just going to have 144 minus 64, which actually equals to 80. So I have to divide both sides by a 16. So if I divide both sides by a 16, I end up having 80 divided by 16, which is actually 5. So it means that the value of x is actually 5 centimeter. It's really easy, isn't it? So you actually use your theorem. You use the information, the knowledge that you have found from the theorem to actually calculate these types of problems. Now, ladies and gentlemen, if you did not understand or you missed something, just try to replay the video or just comment on the comment section or do whatever to reach out, and then we're just going to see how we're going to assist you. But with that being said, guys, I am definitely going to see you on the next video.